Okay, find the largest possible domain for the function. So we just care that the denominator is greater than 0. Because it's under square root, it has to be greater than or equal to 0, and it can't be 0 because it's a denominator. So if we get the quadratic term positive and factor, and this is going to be 3 and 2 minus 3 positive 2, so x is 3 or negative 2, so negative 2, 3, and it is this thing is less than 0 in between negative 2 and 3, and that's the domain. For 18, we've got that. So for A, we have that x minus 2 needs to be greater than or equal to 0, and 10 minus x needs to be greater than or equal to 0. So for this one, x is greater than or equal to 2, and x is less than or equal to 10. So that's in between here and here. So we've got 2 to 10. And for B, okay, so we still have x minus 2, so that's x greater than or equal to 2, and x minus 10 has to be greater than or equal to 0, so x has to be greater than or equal to 10. So if we have 2, that's like all of that. That's an arrow. Okay, and then if we have 10, it has to be greater than or equal to 10. So the only time both of these things happen is here. Okay, so this is our domain. All right, for this one, this is with graphing calculator. So we want to sketch it. Okay, so if we go to the graph, and we can go menu and then clear all this stuff. Yep. Okay, and then we're going to tab, and we want to put in square root of bracket x minus 1 close bracket. I always put multiplication in between brackets because it can be weird. 5 minus x, close bracket, and then we need to go outside of the function plus 1, and that's going to be a vertical shift. Okay, so then enter. Okay, so you can change your window settings to exactly what you see on the graph. So the x-axis is going from negative 2 to 7, and it's going by ones. The y-min is from negative 2, and it's going up until 5, and it's also going by ones. So that's your graph. I think it's pretty clear to see all of the points, but we'll go through another one if it's to do with a max or a min or anything. So we are going to put 1, 1, whoops, 1, 1, and then 3, 3 is the center of, or not center, but, and then 5, 1, and then do your best. Ooh, you know, something like that. Okay, write down the range. So the range is in between 1 and 3. It's just the y's between there. We're using all of them. And, oops, that's a y. Sorry, I'm writing weird. 2, 3. And consider the equation f at x equals k, so it's a constant. This is going to be a horizontal line, so like that. Find the number of solutions if k is 2. So if k is 2, that's a horizontal line through there. So it's going to have 2 solutions. And given that the equation has exactly 1 solution, find the value of k, that is going to be at 3, okay? Everywhere else it has 2 solutions, all right? For 20, we want that x minus 1 is greater than or equal to 0, and that 5 minus x is greater than or equal to 0. So x is greater than or equal to 1, and x is less than or equal to 5. So if it's got to be in between 1 and 5. And the range, this you'll want to graph on the graphing calculator. So it's a function that looks kind of like this. All right, so you need to find, you can, okay, so what you can do is this menu trace, graph trace, so menu 5, 1, and you get this little like target thing, and you can just type in the number. So if you type in 1, the left endpoint, that's going to be 1, 4. And then immediately you can type in another number, which is going to be 5. And you see that's also 5, 4. So the lowest y that you're using is 4. And then the highest y, we need to find the maximum. So menu, analyze graph, maximum, and you need to go to the left and the right side of your maximum, and that ends up being 5.66. So that's your upper bound of your range. Okay, so write down the largest possible domain of f. We just have that the denominator can equal 0. Okay, so for b, I, the y-intercept is when we substitute in 0 for x. So we're just going to have 2 over negative 1. So 0, negative 2 is the y-intercept. The x-intercept is when we substitute in x for y. And we can cross multiply, and then x is negative 2. So negative 2, 0. F at 2 is when we substitute 2 in for x. So that's going to be 4 over 1. And solve the equation. So here we're going to have 2 equals x plus 2 over x minus 1. And we cross multiply. 2x minus 2 equals x plus 2. And then we're going to have x equals 4. All right, so this point for C was 2, 4. And this point was 4, 2. Okay, so for this one, A, if we want f at 2, we're going to have 5 squared minus 3, so 25 minus 3 is 22. If we want the y-intercept, we substitute in 0 for x, so that's 1 minus 3, negative 2. So we're going to have the point 0, negative 2. Double I is when we have the x-intercept, so 0 equals 5 to the x minus 3. You can do this with nsolve. I'm going to warm us up for logs. So we're going to have 5 to the x equals 3. If we do the natural log of both sides, the x drops down. And x is going to equal natural log 3 over natural log 5. You can also write this with a different base. The 5 is on the bottom, and the 5 is the base, and 3 is the what you're taking the log of. So for C, f at x equals 2. So if we have 2 equals 5 to the x minus 3, add 3. And I think we can clearly see that x is 1. Okay, so this is with graphing calculator. we can put these into the graphing calculator. I'll show you both ways actually. Okay, just so you see log base 5 is 3. All right, so if we go to this way, we can do algebra, polynomial tools, find roots. This is degree 3. And we have to get it equal to 0. So if we get everything on the left side, we're going to have 1, negative 2. We're going to have negative 5 and positive 2. Okay. And then just enter. All right, so those are your 3 x's, okay? Those would also be, if we were to do this graphically, and hold on, so we would have, so if we did a graph of this, this is the x cubed, whatever. The zeros are negative 1.68, 0.35, 8, and 3.32. 3.32. Okay, so this is a positive x cubed, so it's going like this, all right? Just like x cubed graph goes like this, it's the same. If it was negative x cubed, it goes like that. All right, so we want to know for B when, because this is when it's like minus that whole thing, and that's greater than 0. So we want to know when this thing's greater than 0. It's when it's in between negative 1.68. And I always put in an equality here because we've rounded negative 1.68. So it's not exactly equal. And 0.358. So that's when it's above 0, as well as after 3.32. Okay? If we were doing this by the graphing calculator way, we can, all right, clear that. All right, so what we can do is we can put in x cubed. All right, there's x cubed. And then we can put in the 2x squared. 2x squared plus 5x minus 2. Okay. All right, so what we would want, let's go back to standard. We want this intersection and this intersection. So if we do menu, analyze graph, intersection, we want the left. So there's the negative 1.68. And then here is going to be the 0.358. And then we actually have to zoom out to see the other one. So if we zoom out up here, keep going. So I know it's hard to tell, but we'll have another intersection up there. Okay, intersection. So if we go, there's the 3.32. All right. Then the other way, or not the other way, but the B one is if we want to see when x cubed is greater than, so let me go back to the standard. We want to see when the blue function, x cubed, is greater than the red function. Okay, so here, the red function is larger than the blue function. It is literally above that. Here, from here, this intersection to this intersection, the blue x cubed graph is literally above the red graph, okay? And then from here to, let me just do this. Sorry. Window, settings. If I just make this go up to, let's say 20. Oh, nope, more. Sorry, guys. All right, let's do 50. Okay, so yes, what I was saying, the graph is, let me move that. Okay, so the blue graph is above there. So the blue graph is above, in between there, and then the red graph is above it, and then after this point, the blue graph is above it, okay? So that's corresponding to those answers there, all right? Okay, the last way to do this is like I did in my sketch here. You can get it all on one side, like the x cubed minus all of 2x squared plus 5x minus 2, and then graph it and just see when it's above the x-axis. Okay, I'll do the next one like that. Okay, so for this one, I just put it in the graphing calculator. It's in radians, it tells you that. And I did menu zoom trig because it gets you from negative 2 pi to 2 pi, so it gives you a nice view. So if we want to sketch the curve, you need everything that is important. So you need the y-intercept, and that you get by doing menu trace, graph trace, and you type in 0. So 0, the point goes to 0.841. So 0.841 there. Okay? All right, now we need the x-intercepts, and that's when you do menu, analyze graph, 0, and you go on the left and the right side of all of your intersections. So first I'm going to have 1.07, then I'm going to have 2.64, and that should be the last one, I think. So then, I'm just checking to make sure that's the last one. 4.2, yeah, it's above. Okay. All right, so then we need the maxes and the mins. So menu, analyze graph, maximum. You need the left and the right side. So the first one's at 0.2851. 0.2851. Okay. And then the next one is at 3.431. Okay. Now we need the minimum. And that's happening at 1.86, negative 1. And then you connect it nicely as possible. And technically 3.43 is outside our domain, but whatever. Yeah, actually what I would do, because I have seen that in questions, do menu trace, graph trace, and then type in pi, and that's going to be 0.841. So technically at pi, which is about there, you should have 0.841. So pi 0.841. So do not put any of that. You want your end point from 0 to pi, it says here. Okay? Find the x coordinates of the max and the min, giving your answers correct to one decimal place. I've already done that. Okay, so I've already got the graph put in here. On the grid below, sketch the curve indicating clearly the point P on the curve where the function has a max or min value. So the first thing you want to do is menu trace, graph trace, and we type in 0, the endpoint, and 0.3. Okay, and then we type in the other endpoint straight away, 3, enter. That's 0.965, 3.965. Okay, next we want to do the maximum, or well, okay, you see the maximum is actually, it's before 0. So we just want the minimum. So analyze graph minimum, and we want the left and the right side. So that's 1.74, negative point. So 1.74, negative 0.472. That's P. And then we need our x-intercept. So analyze graph 0, 1.26. And again at 2.26, 2.260. And then you just have to draw this as best as possible. Something like that. Whatever. What's probably even better is if I would have done the window change, because then, you don't have to deal with anything. So 0 to 3 by 0.5, and y-min is negative 4 to 4 by 1s, and enter. What? Oh, 0. So yeah, that's how it should look, which is not bad. All right, write down the solutions of f at x equals 0. So what you can do, and you can do this always instead of n-solve, which n-solve's good for like linear equations or exponential, but if it's quadratic or something like this, where it's going up and down, it might have more than one solution like this does. You need to put in a second function. In this case, it's 0. F at x equals 0. So I've already done that. It's actually my 2x intercepts. So yeah, x is 1.26 or x is 2.26. And then the range is from the lowest value of y, which is negative 0.472. And I don't put equals because it's not exactly equal to that, up until we can put 3. Okay? Okay, here's the graph of that, and to scale to the domain they want, and I just put their range as well, from negative 2 to 2. And we need endpoints. So if you go to trace, graph trace, and you can type in negative 2, enter. And for the 2 to the x function, that is 0.25. Oops. So I'll keep with the blue. Negative 2.25. It's going to get messy. And then we can even go down to the other function. So negative 2, negative 0.416. All right, and then we need the endpoints for the 1. So that's at 0.54. Oh, I should have done that in red. Okay, so that's 1, 0.540. And then if we move it up, that's at 1, 2. Then we have minimum, or not minimum, 2 to the x won't have a minimum. So really we can just connect those two like that. And the cosine will have a maximum. So if we do analyze graph, maximum, and we want the red graph, and we go here to here, it's at 1. Okay. So I'm going to have to delete my blue line because it needs to kind of go like that. Well, no, it's going, okay. Shoot. It's also going through here, so it's like this. And then the red function has a max here that's going like that. do the best you can. Okay, so the equation 2 to the x equals cosine x has a solution in between -2 and -1. That's going to be here in green. So we can find that intersection by doing menu 6, 4. We need the left and the right side. So that's -1.08, 0.474 for B. Write down the x-intercept of the function to the x minus cosine x between -2 and -1. Well, it's going to be -1.08. So if I tab and I put in that other function, 2 to the x minus cosine x, so see this x-intercept here of the black graph, yeah, they're the same, okay? Okay, so here's the graph of sine of 1 plus sine x. And if we want it from 0 to 6, we need to get the graph trace. We need 0. All right, so that's happening at 0.841. And just make sure and label it. And then we need the maximum. So 0.6071. So about there, and label it. I'm telling you to label it. And then we've got 2.531. And then let's just see where this maximum is. See, that one is 6.89, so it's outside, okay? All right, now we need some minimums. Minimum. We need this one, 1.57.909. 1.57, so like there. Label it. 4.710, so there. And I should have done this with the graph trace, but we need it at the end 0.6. So 0.65660. 6, about there. Okay, so we're gonna have like this, like that. Okay, so yes, the x coordinates of max and min points, don't forget to write that. And then we've got the range is going to be from 0 to the max, which I didn't write down, but I think it was 1. It was 1. Yeah, okay. And it says to 4 significant figures, okay? So be careful of that. Okay, so I've already got the graph of this up. Okay. So, yes. If we want f at 7, we need to do menu trace 1 and then just 7. So that's the answer, 1.97. Solve f at x equals 1 in the given domain. So if we want to solve an equation, we can just type in 1 and find the intersection. So intersection, and this is from 5 to 10, it says in the domain. So if you see here, that's outside the domain, 2.8. This is 6.62, so x is 6.62. And I probably have to get it again because it doesn't register, but it will here. 9.08 is the other one. Okay, so when is it above? When is it above 1? Well, that's in between 6.62, no equal sign, and 9.08. So it's above, just in the graph here. All right, and 5 is like there, okay? So, yeah, okay. Okay, I'm just changing the window, so we're going from 0 to 4 by 1s and -3 to 3 also by 1s. Okay, so this is our graph. They already have g at x down there, and we just want to graph 3 sine 2x. Oh no, they've graphed f at x. We want to graph the polynomial. Okay, so we need the zeros of the blue graph, which is happening at 2.16. Label it. And 3.24. A little bit after the sign. And we need the end point, so we'll do trace. We need 1, which is -13. Okay, great. Down there, and 4, which is -7, also down there, so we can't graph either of those on this graph. But if I go back to standard and we find the maximum of the blue graph, and here, so 2.7, 1.45, so about, it's halfway in between our x-intercepts. And the last thing we need is the intersections between the two. So we want this one, which is 1.89, negative, so this one's looking like this. So that's the negative, 1.89, negative 1.80, it looks like it, label it. And then if we go over, that's the 3.18, 0.268. Okay, and label all these points. Okay, one solution is 1.89. So that was the previous one right there. The other one is 3.19. So h is g minus f. Given that h is less than 0, so g minus f is less than or equal to 0 for p to q. Write down the values of p and q. So we want, g to be less than or equal to f. So we want our polynomial to be less than, so our blue line to be less than, undo. Sorry, I've ruined that. Tab, we'll fix it. It was 3 sine 2x, enter. Okay, so again, we want our blue line to be less than our g function, our quadratic parabola, to be less than our red line. So here, on the graph, here in black, that is above the red line. So we want the ones less than the red line, which is here and here. It's below the red line there. Okay, so this is happening when x is less than 1.89, okay, or when x is greater than 3.19, okay? Okay, I've already graphed this x sine x, and what I did to graph this is I did 1 minus x divided by 3, okay? So that is the red function. So if we want to know all coordinates of the points of intersections, we need to find all intersections. So we can start all the way over here. I mean, obviously that's outside of -3. We can just start moving along. So that one's good. So -2.67, 1.22, that's 1. Then we have, okay, -0.827, 0.609. That's the next one. What? Okay, the next one is 0.439. 0.187. All right, and I'm going to have to get another intersection. So, because we want this one, which is 3.38, negative 0.793. And, oh, actually, no, that one's not in there. So it's just those three, because we just have the domain from negative 3 to 3. Okay, so I've already got this thing in the graph, and we know this, well, it's very clear to see. This is this thing, okay? So we just need to find that 0. Which is 9.42, so that means m is 10. Because in between 9 and 10. I don't know why this is a star, but okay, then we need to find the max. Max here. So the maximum is at 5.45. So that means this is 6 and this is 5 because this is at 5.45. Okay, so for these two, we want to, given that x is greater than 0, find the solution of the following system of equations. So this one we have to solve for y, so we cross multiply and then divide by 3. And that is going to be the blue one there. And then this other one, we have to factor out a y, and that's going to be x minus 1 on the inside. And we divide by x minus 1. So that's that one in red. And if we want to find the solution, we need to find where it intersects. So we have to do menu, analyze graph, intersection, and we want that one. So we're solving for x, so x is negative 0.845. And then I think probably the best thing is just to zoom out, even though it said, oh, see, there's another one right there. So menu, analyze graph, intersection, here and here. So 1.5 is the other answer. All right, so for this one, if we want to complete the table of values, for 0 to 5, not including 5, so just for 0 to 4, it's this function. So 0 minus 2, 1 minus 2, 2 minus 2, 3 minus 2, 4 minus 2, and then 5 to 6 is going to be this function. So 5 times 5 minus 22, and 5 times 6 minus 22. And if we graph this, 0, negative 2, 1, negative 1, 2, 0, 3, 1, 4, 2, 5, 3. So that gets a line. And then we have 6, 8, which gets another line. These are both linear functions, x to the 1. Write down the domain, so that's good from negative 2 to 6. And the range is from negative 2 to 8. And the x and y, so the y-intercept is 0, negative 2, and the x-intercept is 2, 0. All right, last one, consider the cubic function. The graph passes through the origin, and those points find 3 linear equations. Okay, so we have the form of the function up here. So we're going to use these 3 points and substitute them in there. So we're going to have negative 8 equals p times negative 2 cubed plus q times negative 2 squared plus r times negative 2. And then we're going to have negative 2 using the point B. Negative 2 equals P times 1 cubed plus Q times 1 squared plus R times 1. And using the point C, we're going to have 0 equals P times 2 cubed plus Q times 2 squared plus R times 2. All right, so in red, I'm just going to write the simplified versions of these. Negative 8 equals negative 2 cubed is negative 8P. That's 4Q minus 2R. So this is our first. Our second is going to be negative 2 equals P plus Q plus R. And our third is going to equal, 0 is going to equal 8P plus 4Q plus 2R. Okay, so then if we want to solve this, we need to go to algebra, polynomial tools, nope, not polynomial tools, solve system of linear equations. We've got 3 of them, and I'm going to change this to P, Q, R with commas. Okay? Enter, and now we just put these red ones in. So we're going to have negative 8 equals negative 8P plus 4Q minus 2R. And then we've got negative 2 equals P plus Q plus R. And we have 0 equals 8P plus 4Q plus 2R. And then you just push enter, and there is our solution. So we've done A here. B, P is 1. Q is negative 1, and R is negative 2. Now, if we put this into the function here, so tab, up, clear, and we've got 1x cubed plus, minus x squared, negative 1 minus 2x. That's our function. It looks just like what they've given us. The largest possible domain, the domain is all real numbers. We can substitute any value in there, it's fine. The range, also all real numbers. It goes up and down forever. Now solve the inequality. When is f of x greater than 0? Well, that's happening here and here. So we need to find those x-intercepts, which I think you can see what they are. Well, also I think just in case. So we need to analyze graph zeros. Here's the first one, negative 1. So this is negative 1, 0, and then we have that one, that's 2. Okay, so that means it's above y equals 0 from negative 1 to x, negative 1 to 0, or x greater than or equal to 2. So that's the answer to D.